Moving right along in Chapter 9, we're going to start using our unit circle a little bit more aggressively, shall we say. So let's see how. Finding the exact measures of special angles. Well, what do I mean special? Oh, that looks like something Mr. Kinnear might have taught you. A 30, 60, 90 triangle. Hopefully you remembered this. He probably taught you the ratio that across from the 30 angle is 1, across from the 60-degree angle is radical 3, and across from the 90-degree angle is 2. Does this sound familiar? The ratio of 1 radical 3 to 2? Maybe he called it x to x radical 3 to 2x? Not sure, but I know you did it because it's standard in geometry. Likewise, we have over here another special triangle, a 45, 45, 90 triangle. And its ratio is, across from the 45 is 1, well then across from this 45 is 1, and across from the 90 is radical 2. And notice they went in order, from smallest angle to biggest angle. So over here it went from 30 to 60 to 90. Well, these angles with these measures of 30, 60, and 45, 45 give me the nicest numbers to work with in trigonometry. 1 to 1 to radical 2, 1 to radical 3 to 2. And the Greeks found a lot of good discoveries with these. All right, so here is what I'm talking about being more aggressive with the unit circle. By now, we know this is 0 degrees, 90 degrees, 180, and 270. So now we're going to start playing around with our special reference angles. Ugh, what does all that mean? I'm going to take my protractor, put it out here, make it a little bigger so you can see it. It's not playing well. There. And we're going to find the exact measure of the sine of 240. Now I know Johnny's already whipping out his calculator going, this is easy, Mr. Trulin. Sine 240. Oh, but look at that dirty decimal you get. If you did it on your calculator, you would have gotten as an answer negative 0.8660, and that's a dirty decimal. I want the exact answer. So let's have our unit circle over here help us. First off, I'm going to open this triangle, I'm going to open this protractor up 240 degrees so I can get a good visual. There's 240 degrees. Now, how do these triangles come into play? The Greeks couldn't use a triangle that had 240 degrees in it. Really? That's impossible. Triangles only have 180. So they had to use reference triangles. So if I took the time to draw this triangle over here, there's my radius of my unit circle. I went down and over to some point on my unit circle. Now this is a rough drawing, but watch what happens. This triangle, and I'm going to change its color so it sticks out a little better. If I played with this triangle, and I rotated it, and then I flipped it, look what happens. Hey, it fits right over the triangle the Greeks were. So the Greeks saw that this triangle and 240 degrees were similar. In fact, that angle that you formed right there with 240 was a reference angle of 60 degrees. So now they could refer to 60 degrees. So this triangle was really a 60, 30, 90 triangle in disguise. So across from the 60 is radical 3, across from the 30 is 1, and across from the 90 is 2. Now, what I can say is the sine of 240 is related to the sine of 60. And both mean to take the opposite and put it over the hypotenuse. And we realize that it's a negative, right? We got that when we cheated on our calculator. And it's negative for two reasons. One, this is a direction of -1. This is a direction of negative radical 3. This is a positive direction because it's the radius of 2. So I get negative radical 3 over 2. And if you did negative radical 3 over 2 on your calculator, you could see that you get negative 0.8660. So now, of course, the next thing you're asking is, yeah, right, Truls, like, I'm going to know that that's 60 degrees. How did you figure that out? Well, you're practicing today, and you're only going to be using one of these triangles. You're only going to be using a 30, 60, 90 triangle or a 45, 45, 90 triangle. Let's make that one white. And once again, you're going, well, how did you know that? How come you didn't start flipping this 45 one around in there to make it fit? Well, because I'm going to go back and I'm going to look at this 180 right here. See, when I had the triangle right there, I know that I went 240 degrees. But from here to here is my reference angle. So all I did was 240 subtract 180, 60. That must be my reference angle, 60. So I'm going to use my 30, 60, 90 triangle. Let's try another one. Find the exact measure of the cosine of 315. Well, I'll use my protractor one more time. I'll go 315 degrees. And there is my angle. So let's be Greeks. Let's create a triangle out of this angle. I went over, and then I'm going to go down, and then I'm going to create a radius out of that. And now I have to decide which special, because we're only doing the special ones today, which special one was created. Was that a 45, 45, 90 triangle? Or was that a 30, 60, 90 triangle? Well, let's just do some advanced math. I know that I traveled all the way around, and that was ending right here, was 315 degrees. This is my angle. I've got to figure out how big this angle is. Well, if this is 360 all the way around, what's the difference between 360 and 315? 45. Oh, so that must have been a 45-degree triangle. Let's see. Let's come over here. Let's flip it around. And if I put it in there, awesome. It fits almost pretty perfectly for a freehand that I did. So now that I know that that is, I don't want to delete that. So now that I know that that is 45, I can enter in my numbers and my sides. If this is 45 degrees, there's my right angle, and this is 45. across from my 45 is 1, 1, and across from the right angle is radical 2. Okay, so now they want me to do the cosine. Cosine says take the adjacent side and put it over the hypotenuse. I'll rationalize it, and I get radical 2 over 2. And the last thing I got to decide, is that positive or negative? I should have put my signs in here. Well, this is a positive 1. This is a negative 1. Oh, okay, it's positive. Oh, hey, and that big C right there. Cosine's positive. Cosine's positive. So my answer for that is positive radical 2 over 2. Ooh, secant of 45. All right, so let's try and do some shortcuts here. Well, I know that 45 degrees is going to be in the first quadrant. So I'm just going to take a triangle, and I'm just going to draw a triangle real quickly in the first quadrant. Here and here. Now, I don't have to really worry about measuring whether it's 45 degrees or not, because I'm just going to say it's 45. They told me, go 45 degrees. Okay, so that's 45. And that's my right angle. Across from the 45 is 1, across from the 45 is 1, across from the 90-degree angle is radical 2. Everybody's positive because it's in the first quadrant. Secant. I got to go back to that chart. Secant is cosine upside down. So it's hypotenuse over adjacent. The hypotenuse is radical 2, and the adjacent is 1. And since we're in the first quadrant, all my trigonometric functions are positive. So the secant of 45 is radical 2. And you can check that on your calculator. We'll show you how to do that in class. Find the exact measure of the cotangent of 180. Well, I got the hang of this. 180 degrees means I'm going to go 100. Oh, no. 180 degrees means I end up right here on an axis. I don't create a triangle. All right, what do I know about where I stopped right here? I know that's the point over -1 up 0 because it's a unit circle. I know my radius is 1. And I also know that the x value is the cosine of the angle and the y value is the sine of the angle. Okay, cotangent of 180. Well, I know cotangent is tangent flipped, and I still don't have a tangent over here. Oh, but wait a second. All right, got to do a lot of thinking here. Let's see if you can bear with me. The tangent is the sine of an angle over the cosine of an angle. So the cotangent must be the flip of that, the cosine of the angle over the sine of the angle. Okay, so my angle right here was 180 degrees, so the cosine of 180 degrees is the x value, -1. And the sine of 180 degrees is 0. So -1 over 0 means the cotangent of 180 is not defined. It's undefined because I had a 0 in the denominator. All right, last problem. Find the exact measure of the cosecant of 140 degrees. All right, so 140 degrees means I went 140, so I'm going to end up somewhere over here. Here's my point. Let me Greek it up, draw a triangle, drop this down, drop that down. There's my triangle. And now how big is my angle right here? That's what I got to figure out. How big is that angle? Well, up to here was 140. And this is 180. So my reference angle, how far is it from here to here? 40 degrees. Ah, but wait a second. You don't know how to do this yet, because you only have reference angles of 60, 30, 45, and 45. So we're going to leave this one. You can't do this. So tonight, all your answers are going to be 60, 30, 45, or 45 reference angles. We're going to go over more of this in class tomorrow, because I know it's a little hard at first, but we'll get the hang of it.